Welcome to In 5 Minutes. In this video clip, we will start with the generation of single sideband suppressed carrier signal. This is the third type of AM system after studying DSB-FC system and DSB-SC system. In double sideband full carrier, we transmit two sidebands along with full carrier. In second system, we transmit two sidebands, but the carrier is suppressed. The carrier is not present in the final signal, which is DSB-SC. This was done to improve the power efficiency of the modulation process. Now, to further save half bandwidth, because the information in both the sidebands is same, we will suppress one of the two sidebands also along with the carrier, and hence this will give us a single sideband suppressed carrier signal. Now let us discuss various methods in which we can generate single sideband suppressed carrier. Let me quickly remind you that to generate double sideband suppressed carrier signal, we had used circuits like balance modulator. The second circuit was double balanced ring modulator, and the third circuit was switching modulator. All these circuits will give us output in the form of only the two sidebands. The carrier will not come at the output side. Now let us see how to generate single sideband suppressed carrier. That means we now do not want carrier as well as one of the two sidebands, which could be any one. I can have upper sideband in my final output, in which case I will have to suppress the lower sideband. Or if I want to keep the lower sideband in my final output, I will suppress the upper sideband. Now, let me make one very important statement, that you can never generate single sideband suppressed carrier as the very first output signal. That means you can never generate single sideband suppressed carrier without generating double sideband suppressed carrier. In all the three methods that we will discuss of the generation of SSB signal, we will first have to generate double sideband signal and then somehow remove one of the two sidebands. I repeat, we will first generate double sideband suppressed carrier, that means DSB-SC, and then we will remove one of the two sidebands, and that will give us single sideband signal. And hence, as we had discussed in one of the early clips, that power efficiency of DSB-SC and SSB-SC will be exactly same, because you're not saving any power by not generating, or I would say you're not saving any power by suppressing one of the two sidebands, because to suppress one of the two sidebands is only possible after you have generated DSB signal. That means you have to generate two sidebands first and then suppress any one of them. So if you remember, the power efficiency of 50% that we had obtained in double sideband signal is still the same. The efficiency of single sideband systems will also be 50%. But there is an advantage in terms of saving of bandwidth, because we have to now transmit only one sideband. The very first method of SSB generation is called filter method, which is very simple method and a very obvious method of SSB generation. The block that we have in this method is balance modulator. As I told you, we will have to first generate DSB-SC signal, and we can do that using balance modulator. So the input is nothing but the modulating signal, and the second input will be the carrier signal. When you give it to the balance modulator, the output of the balance modulator is nothing but double sideband suppressed carrier. That means we have got two sidebands. Let me draw the frequency spectrum of the double sideband suppressed carrier signal. It will be present around the carrier frequency Fc, and we all know that it will have the frequencies ranging from Fc minus Fm to Fc plus Fm. The carrier frequency will be absent because it is suppressed carrier signal. We have taken the triangular shape for the frequency spectrum, but please remember that the shape can be anything. We are more interested in the frequency range of the signal, which goes from Fc minus Fm to Fc plus Fm. Now, as we can see that there are two sidebands here. This is the lower sideband, this is the upper sideband. Let us say we want to suppress one of the two sidebands. That means, let's say if I want to suppress the lower sideband and only want to keep the upper sideband, in that case, I will need to remove all the frequencies from Fc minus Fm up to Fc, and allow the frequencies from Fc to Fc plus Fm. To remove the unwanted frequencies and to allow the remaining part of the frequencies in the signal, we use a very famous circuit, which is nothing but that of a filter. So all we need is a filter after the balance modulator. And let's say if the filter that we are using has the pass band which is designed over the upper sideband, in that case we will get upper sideband at the output side from FC to FC plus FM. The lower sideband will not come at the output side. So you can see my output will only contain the single sideband, and hence it becomes single sideband suppressed carrier. So all we have to do is use a filter, a suitable filter to convert double sideband suppressed carrier signal into single sideband suppressed carrier signal.